S5, Chapter 7, Equation of Circles, Lesson 3. Let's do some revision. For equations of circles, we have two formats. One is called standard form. So the center is HK here, the radius is here, and then the equation is x minus h square plus y minus k square equal to the radius square. So HK center, radius circle. You can use this format to present this equation of circle. Next we have general form. General form is x squared plus y squared plus dx plus ey plus f equals 0. If general form is given, we need to find the center and radius by using negative d over 2, that means from here, and then negative e over 2. Next, we find the radius. We will use h square, that means this one square, plus this k square, and then minus f. Okay, let's do an example. For this example, we can see the coefficient of x squared and y squared are 3. So that means we need to change to 1 by dividing 3. So whole equation divided by 3, so it becomes x squared plus y squared, and 12 divided by 3 is 4, and negative 24 divided by 3 is 8, negative 8, and finally negative 15 divided by 3 is negative 5. If we want to find the center, we'll use negative d over 2, so negative 4 over 2, and then negative e, negative 8 over 2. So it is equal to negative 2 and then 4. Next, for the radius. For the radius, we use this one square plus this one square minus f, negative 5. Take square roots. We'll place the number inside the square roots. We can get 25. So square root for 25, we can get 5. Next, we'll do some revision for distance formula and then midpoint, because we may use it for some question. So for distance formula, we have two points, point A x1, y1, and point B x2, y2. If we want to find the distance, it is x1 minus x2 square and then plus y1 minus y2 square, then take square root. If we want to find the midpoint of AB, for example, we have a point called M. This distance is equal to this distance. So for the coordinate of M, it is x1 plus x2 divided by 2, that means this one plus this one divided by 2, and then y1 plus y2 divided by 2. Then we can get the midpoint of AB. Now, try to use few minutes to do A. Let's check it. For this question, we need to find the equation of circle in standard form. So let's see. You can see the center is negative 5, 0. And for the radius, actually is a point from center to circumference. You can find this point to this point. Actually, you can use distance formula, or simply you can see from negative 5 to negative 8. Actually, it goes 3 steps. So that means the radius is 3. Then we can use the standard form, x minus bracket negative 5 square, and then plus y minus 0, because of this, square equal to 3 square. So it is x plus 5 all bracket square And y minus 0 is y, so y squared, and finally 3 squared is 9. Okay. Next, try to do question B. Okay, let's check it. For center, it is given. And for the radius, we have these 2 points. So we can use distance formula. So -3 minus bracket -2, or bracket square, and then plus 5 minus 3 square. Take square roots. So we can get 1 square plus 2 square roots. Remember, place the number inside the square root, so we can get 5. So square root 5 is the radius. Next, we'll use the standard form. So center radius, we have it. So x minus this one, -2 square, and then plus y minus 3 square, and then equal to the radius square. So after simplification, we can get x plus 2 square plus y minus 3 square. Finally, it is 5. Okay. Next, try to use few minutes to do this question. Okay, let's check it. For A, we need to find the coordinate of C. You can see C is the center, and then we can see it is a midpoint. So for coordinate C, we use the midpoint formula. So 4 plus 0 over 2, 4 plus 0 over 2, and then 1 plus -3 over 2. So we can get the answer 2, and then -1. It is center. Next, for part B, find the equation of circle. We have center, that means we need to find the radius, and then so that we can find the equation of circle. So for radius, we can use point C to point A, or point C to point B. Actually, you can choose anyone, but I will choose B. Do you know why? Because there's a 0 here. That means for point B, actually is a bit beautiful. So we'll choose point B. So find the distance. Okay, so distance formula 2 minus 0 square, and then plus -1 minus -3 square, and then take square roots. So you can use calculator. So after calculating, we can get square root 8. We have center, we have the radius, so we can use distance form. We can use equation of circle center form, x minus 2 square plus y opposite, so plus 1 square equal to square root 8 square. So x minus 2 square plus y minus plus 1 square equal to 8. It is the equation of circle. Next, we'll talk more about equation of circle. For this section, we'll look at a point. This point will lie on outside circle, on the circle, or inside circle, like this. If it is a circle here, we have a center point. If the point inside the circle is here, okay, on the circle is here, and outside the circle is like this. Okay, so we talk it one by one. For outside the circle, actually, how to check this point is outside the circle, we'll check with the radius, compare with the radius. You can see, for example, we call this point P. If it is outside, so you can see the distance to center, actually it is longer than the radius, right? So checking this point outside or inside, we'll check the distance from here to here with the radius. Okay, next one. If it is on the circle, actually it is the radius. Okay, it is the radius. So exactly the radius if it is on the circle. Lastly, case 3. If it is inside the circle, that means you can see the distance of center and the point P, it is smaller than the radius. So it is called the inside the circle. Okay, remember, check the distance and then compare with the radius. Okay, let's see this example. We have an equation of circle like this. Find the center by using this negative 10 over 2, so it's negative 5 for center, negative 5, and then for k it is negative 4, so negative 4 over 2, so it's 2. And for the radius, we use 5 square plus 2 square minus this one. That means negative 7. Take square root. We can get it is 6. Okay, so center and radius. Now we need to see, we need to determine whether the point lie on inside or outside the circle. So let's see this example. There's a point P, negative 10, negative 1. So we can see the distance from center to P. We found the distance. So it is negative 10 minus bracket negative 5. Now we compare with the center with this one. Okay, square, and then plus negative 1 minus 2 square, and then we take square roots. After pressing calculator, we can get inside the root is 34. You see, it is around 5.83 by using calculator. You can see this distance, it is less than 6, less than the radius. So, as I said before, if it is radius 6, if the point is 5.83 only, that means it's around here. Okay, point P here. So that means it is inside a circle. So the point lies inside the circle. Okay. Now try to do question 2 and question 3. Okay, let's check it. For question 2, we have a point Q, so CQ, we check the distance. So negative 9, like compare with this one, negative 5, all bracket square, and then 7 minus 2 square. So we can get square root 41. So you can see by using calculator we can get 6.40. This number you can see it is bigger than the radius 6. So that means it is radius here, 6 point something is here. So that means it is outside the circle. So the point lies outside the circle. Okay. Next, question 3. Now we found CR. So same, negative 5 minus negative 5 square, and then negative 4 minus 2 because of this square. take square roots. So it is square root 36. It is 6. It is exactly the radius. So that means it is on the circle. So the point lies on the circle.